Good evening to all. We are from Chem Academy. Those who are appearing for Neet 2025 on May 4th, all the best for your the aspirants, Neet 2025 aspirants. We are from Chem Academy, right? Now, in the lecture series, today's topic is thermodynamics. बेटा आज का टॉपिक है thermodynamics, right? We have covered the quantitative elemental analysis in one video, and we have covered chemical kinetics in one video. This is a third video of nearly it will be a 15 to 20 minutes duration. Okay, now in this we are going to mainly concentrate on the formulae and graphs and topics related to your which are there in your NCR textbooks. जो नीट एग्जाम लिख रहे वो एक चीज पे ध्यान देना चाहिए. आपका नीट एग्जाम में जो प्रश्न पूछ रहे जो एग्जामिनर जो प्रश्न पूछ रहे वो पूरा एनसीईआरटी टेक्स्ट बुक से ही आ रहे. Nearly 80 to 90% they are from NCR textbooks. I'll show the evidence also. Okay. Now, I hope you all are having the previous papers. Just keep the 2024 paper and 2023 paper with you. You check the quantitative elemental analysis which we were discussed in the last video, and also the in chemical kinetics which we were discussed in the yesterday's video, and the thermodynamic topic which we are going to discuss today. You check the questions. They are direct bits from the important formula, important graphs which were there in your NCERT textbooks. But ये बच्चे क्या कर रहे हैं? उनको छोड़ के बाकी मेटेरियल पूरा पढ़ रहे. In the exam, you have to know what to read, what not to read. That is also very important. जो कोर टॉपिक से आप जो सिलेबस में है और जो टेक्स्ट बुक में है वो उनको छोड़ के आप बाकी पढ़ रहे हैं, उनका you never get you don't get marks, right? But if you spend 15-20 minutes of the core topics of 20 topics, I hope you have the syllabus of NEET 2025. How many chapters are there? 20 are there, right? So 12 है फिजिकल में और 4 में इनऑर्गेनिक और रिमेनिंग आर फ्रॉम ऑर्गेनिक. ओके, 20 यूनिट्स में a lecture series है ना, third one. We are going to cover in the next 17 topics also in the coming next 17 days. We are going to release that 15-20 minutes video of on a particular chapter, important topics from the NCR textbooks, which will definitely help you to crack the NEET exam. ये ऑलरेडी हम कवर कर चुके हैं, मगर जो इंडिया में जो अरुणाचल प्रदेश में या कश्मीर में या केरला में उनके जो हमारा वीडियो देख रहे हैं ना, उनका एटलीस्ट दे विल गेट आउट ऑफ 45 एटलीस्ट they have to score 30 from the revision notes from the lecture series of 15-20 minutes duration and every day. Okay, now today we are going to discuss about the thermodynamics. Now thermodynamics beta आप ये इंटरफर्स्ट में पढ़ चुके. Most of the NEET people, biology people, they will feel tough, hard to understand these thermodynamic topics. But if you go through the NCERT material, it is very easy. Okay, now as you know, you'll be asked 50 questions. So how many topics are there? 20 are there. Roughly you'll get 2 questions from each chapter. 2 questions, 2 प्रश्न आप examiner पूछेगा from this unit, thermodynamics, right? So you'll be asked 2 questions from thermodynamics. Now, I hope you have the previous papers also, 24 paper, 25 paper. If you see those previous questions only, then you can understand actually how the examiner is asking, from where he is asking. जो 90% they are asking from NCERT textbooks. 10% बाकी थोड़ा extra application से पूछ रहे. Most of the students, what they are doing is they are concentrating on 10%, leaving 90%. Don't do that. We are ready to help you in the coming 17 days also. You have 25 days time is there. We are going to take this is the third series. Remaining 17 also will cover the coming 17 days, which will definitely help you in cracking that NEET examination. Right now, अभी हम ये शुरू करते हैं. Thermodynamics. If you see here, I wrote 18 important formulae in thermodynamics. These are directly from I have taken from the NCERT textbook. किसी को डाउट आएगा क्या ये आठ फॉर्मूले से आएगा? जरूर आएगा. If you don't believe, just you check the 2024 paper and 2023 paper. We'll also discuss here. Now this one. इसमें आप पढ़ेगा. I'm not going to discuss about the fundamentals, that is basics. You are studying the system, surroundings, types of systems, closed system, isolated system, open system, right? And some terminology like isothermal process, adiabatic process, isobaric process, isochoric process. Yeah, on these definitions, they have asked one question in 2025. Just please check it. Please check it. It is there. It is there in the NCERT introduction also. That is terminology also. They have asked match the following: isothermal process, isobaric process, isochoric process, adiabatic process. As you know, isothermal means temperature and heat will temperature and internal energy will be constant. Isobaric, pressure will be constant. Isochoric, volume will be constant. Adiabatic, heat will be kept constant. That is there in textbook or any किसी भी material में ये रहेगा. Okay, this will be there in all material, whichever you can check it in, whether it is in X institute or Y institute. Okay, it will be there. Now after that you will be having some more properties like intensive properties, extrinsic properties. Just go through the examples, and after that state functions, path functions, definition of enthalpy, internal energy, like this. Okay, now after that we'll directly move to the laws of thermodynamics. There will be zeroth law is there, first law is there, second law is there, third law is there. But in your syllabus, you have to focus mainly on first law and second law. Okay. Now first law. So first law is also known as law of conservation of energy. This is a mathematical form of the first law of thermodynamics. So here I wrote 8 formulae. In that first one is, this is a mathematical form of first law of thermodynamics. This is a change in internal energy delta U, which is equals to Q plus W. That is heat supplied to the system and work done. Work done and work done. Okay. And this work done can be also, you studied 2 types: work done by the system, work done on the system. Okay. But you remember this one. So this is a mathematical form of first law of thermodynamics. So change in energy equals to Q, heat supplied plus work done. Now second one, in chemistry, in thermodynamics, will mainly focus on, so here it is not thermodynamics, but it is a work done by gases. So we're going to discuss about the gases. So the gases, they can either do, they can go expansion, or they will be compressed. They will be compressed. Now in that case, volume will be reduced. In the expansion, volume will be increased. So in any case, work done in thermodynamics on gases can be given as a formula: W equals to minus P external pressure into V2 minus V1. That is nothing but minus P delta V, change in value, final value minus initial value. Next, third formula. Now you see here, suppose just like reactions, the process can be of reversible process, irreversible process. You will be knowing that in the terminology it is there. Process can be of different process, like just now we told you. Apart from that isothermal, isobaric, isochoric, adiabatic, there will be a reversible process, irreversible process, cyclic process, right? So reversible means which occurs infinitesimally slowly, and at any point of time it can reach to its initial state. Such a process is said to be reversible process. And irreversible process means which occurs in one direction, only one step. There is no backward reaction. There is no backward step. Such reaction is said to be irreversible. Now here in this case, reversible. there is a derivation of one formula is there, work done in isothermal reversible expansion, work done in isothermal reversible expansion of an ideal gas. Now the formula is work done in isothermal reversible expansion. The formula can be written as W reversible is equals to minus N number of moles, R gas constant, T temperature in Kelvin scale, ln that is log base exponential log E, V final by V initial. That is in the expansion what happens? Volume increases. So that is the volume, final volume by divided by initial value. Now, as you know, since it is isothermal process, that means temperature is kept constant. At constant temperature, the relation between volume and pressure is inverse, both are inversely proportional. So instead of here, if I write V final by V initial, we can also write slight change. We can write, if you are using pressure terms, P initial by P final. P initial divided by P final. The remaining thing will be same. It is there. It is directly there in your textbook. But in 2025, as I told you, one question they asked on the fundamentals, the processes on one question. Second question is on this one. But here they gave, instead of volume, they gave pressure. So in this case, you have to apply P initial by P final. Initial pressure by final pressure. Just you check the 2025 paper. Those are the two questions asked from thermodynamics. And आप क्या पढ़ रहे हैं आप? कौन सा वीडियो आप देख रहे हैं? Do you want to waste your hours of time for 8 marks? Yes, in 15 minutes we are going to discuss all the important topics, important formula, important graphs, important things, important definitions. Okay. So don't waste your time. This time is very crucial. Now you have 25 days time is there, and we are ready to help you. Just follow our videos. हम हमारे बच्चे के लिए पूरे कवर कर चुके हैं, मगर पूरा जो इंडिया की हर जो बच्चे जो नीट एग्जाम लिख रहे हैं उनको हेल्प करने के लिए अभी हम a 15 to 20 minutes video lecture on important formulae we are planning. So in this lecture series, this is the third one on thermodynamics. So with this is a proof, you can, at least you will be having 3 to 4 years previous papers. Otherwise you keep 23 paper and 24 paper. In 24 they asked second question is this one. So no need of reading all these things. No need of reading all the unnecessary stuff. Okay. It is there in your NCERT books, right? Now, third. So if you substitute this, you will get you can solve any problem, right? Now, next. In these definitions are also there. Enthalpy. H stands for enthalpy. U stands for internal energy. Now, the relationship between enthalpy and internal change can be given as delta H is equals to delta U plus delta nRT. Delta U plus delta nRT. Here delta is nothing but change number of moles. That we have to consider only gaseous products and gaseous reactants. The difference of change number of moles of gaseous products and gaseous reactants. Now R is a gas constant, T is a temperature in Kelvin scale. Now you won't believe this question, this formula they directly asked into Neet 2023. Neet 2023. Which is the relation between the correct relation between the enthalpy and internal energy can be given as one of the option is this one is the correct one. Understood? Is that clear? Yes. Now this time they may ask a problem on this one. This time they may ask problem. So here delta H stands for change in enthalpy, delta U stands for change in internal energy, delta N stands for change number of moles, R is gas constant, T is temperature in Kelvin scale. Okay, you can if you remember the formula, if you substitute the values, you will get the direct value. If R is in joules, It will be in joules. R is in calories, the answer will be in calories. Okay. Now, this you will study in physics also. Heat capacities. Heat capacity at constant pressure, heat capacity at constant value. Otherwise, you can say molar. There is molar heat at constant pressure, molar heat at constant value. The relationship between the two can be given as Cp minus Cv equals to R, gas constant. Actually, this is for 1 mole. For n moles, it is Cp minus Cv equals to Nr. Okay. Now, the relationship between heat capacity at constant pressure, heat capacity at constant value. Okay. Otherwise, molar heat at constant pressure, molar heat at constant value can be given as R. Right. So, this is the fifth formula, which is there in your NCERT textbook. Now, sixth one, what does this delta S stands for? Entropy. Entropy. Entropy nothing but randomness, as you know. I know. You know these definitions. It is nothing but randomness or disorderliness, right? Entropy of the system can be calculated by the formula delta S can be given as it is a ratio of Q reversible. That means heat value of in the reversible process divided by temperature. Q reversible by temperature can be given as delta S. This is a system. Here also Q reversible of system. So this will give the delta S equal to Q reversible by T. Okay. Now, suppose if they want to ask instead of this W reversible, they can ask in the isothermal process what is the change in entropy. In that case, you see here, this will be positive, Q will be positive. Now we can write nRT ln Vf by Vi divided by T. So Tt get cancelled. The value will be only delta S equal to nR ln Vf by Vi. If they gave this value, suppose if they give the pressure Pi by Pf, P initial pressure by final pressure. So these are somewhat extension of this what we know, right? Actually, they have given the formula directly this, but you apply in the application part. We know that W is this one. In isothermal process, Q equal to minus W. So minus W means minus into minus, this becomes plus. So it will be nRT ln Vf by Vi divided by temperature. Tt get cancelled. nR ln Vf by, there will be no temperature term. Delta S, the calculation of delta S. That is a somewhat little bit extension of this, what we know, right? Now, but it is not there in your NCERT. Now, seventh one. Now, as you know that somewhat will give. What does this delta S denotes? Delta S is 0 means it is the system is at equilibrium. Delta S is positive means system is spontaneous process. Spontaneous process nothing but, as you know the definition, right? I know you all people know the definition of spontaneous. The spontaneous nothing but process which occurs on its own is said to be spontaneous process, right? Now, if delta S is negative, non-spontaneous process. That is the thing. Next, to better explanation of that spontaneity of a process, instead of delta S, we are going to use delta G. It is a Gibbs free energy. Right? Now, the relationship between Gibbs free energy, enthalpy, and entropy can given as delta G equal to delta H minus T delta S. Delta G equal to delta H minus T delta S. Delta G, change in Gibbs free energy, enthalpy, temperature, entropy. Now, in this case, quite in the previous case, delta is positive, the process is spontaneous. In this case, delta G negative, process is spontaneous. Delta G 0, system will be at equilibrium. Delta G is positive, non-spontaneous. Now, in your NCERT textbook, they have mentioned 3 spontaneous conditions, 3 non-spontaneous conditions. So here, as I'm saying that it is there, delta G negative means spontaneous. So to get the negative, how can we change this enthalpy and entropy values? If delta H negative and this one is also say positive, so delta H negative, delta S positive. At all temperatures, the process is spontaneous. Now second case, delta H negative, delta S is also negative. But your negative positive will be there. That means at lower temperatures only this will happen. At lower temperatures only process spontaneous. This is the second condition. Now another condition. Delta H say negative, delta S positive. That is also third possibility. Okay. So you can go through the three spontaneous processes. One is delta H negative, delta S positive. So first one is delta H negative, delta S positive. This is the first condition. So negative, positive to negative, negative. So on the whole negative will be there. That is process spontaneous. Second case, delta H is here positive, delta S say negative. This is positive, this is sorry, this is also positive, this is also positive. Now you see here, this is a positive, here positive to negative, negative. So but temperature should be high. That means it is possible only at high temperature conditions. So if both are positive at high temperature conditions. Next, suppose say delta H negative, delta S also negative. Here also process spontaneous, but you see delta H negative, delta S also negative. Negative, negative, positive. That means temperature should be low. That means this is possible at low temperature conditions only. That means only these three conditions leads to the spontaneity of a process. Remaining conditions are non-spontaneous. Okay. One is delta H negative, delta S positive. Second, delta H positive, delta S also positive, but temperature should be high. High temperature conditions only this is possible. Next, delta H negative, delta S also negative, but this one temperature should be lower temperature. At low temperature conditions only this process will be spontaneous. You have to remember these three conditions. This time you may expect question from this one. Next one is eighth formula. It is a relationship between standard Gibbs free energy and also equilibrium constant K. Equilibrium constant K. Now your standard Gibbs free energy can be equals to minus RT ln K. K nothing but equilibrium constant. Concentration of products by concentration of reactants. If they give in the problem, what they do is they will give A plus B equilibrium with C plus D. So they will give the concentrations or otherwise pressures. So in this case, you have to write concentration of products divided by concentration of reactants. Here it is a ln 2.303 log T temperature in Kelvin scale, or is a gas constant. Based on the answer, or you are taken either in joules or in calories. So this is the eighth formula given in your NCERT textbook. That is standard Gibbs free energy delta G naught equals to minus RT ln K. This is the relation between standard Gibbs free energy and equilibrium constant. In 2013, they have asked its second question, calculate the standard Gibbs free energy delta G naught. They have given these concentrations and also these temperature values. So you see here in 2024 and in 2023 they have asked two questions. This year also you will get two questions from thermodynamics. So this hardly takes how much? It may take 25 to 30 minutes. Quick revision. First you finish the NCERT important topics and we are ready to help you. So this is the third lecture series. We are going to discuss remaining 17 units out of that is the leftover 17 units in the coming 17 days. So all the best from ChemG Academy.